Hello Eng 1060. In this video, I will cover how to plot multiple datasets. So as you recall from the last video, the syntax to plot something in MATLAB is plot x, then y. X is our independent variable, and y is our dependent variable. Multiple plots can be drawn on the same figure. We still use the same plot function. Simply, we have plot our first data set, which is x1, y1. Then our next data set, x2, y2. And then x3, y3. So this will plot 3 sets of data. Some other complementary functions for the plot command include legend, hold on and hold off, grid on and grid off, and also figure. So the figure command creates a new figure window. Close all closes all of the figure windows currently open. Hold on will hold and not overwrite the current figure window. If you were to use 2 plot commands in sequence, the second plot command will overwrite the first one. So if you'd like to have both, you need to use the hold on command. Grid on will turn on the grid axes. The legend will turn on the legend with keys. Subplot is something that I'll cover later in this video. Axis can set the range of your x and y axes. So as an example, here we have plot of x versus y1, which is our first data set. Our second data set is x versus y2, and our third data set is x versus y3. Now you'll notice that there are additional arguments for all 3 data sets. For the first data set we have rs, which is red squares. For the second argument we have kx, which is black crosses. And for the third set we have bo, which is blue circles. Following that, we have the X label, Y label, and title, which should be on all of your plots. And finally, we have the legend. So the legend accepts strings as arguments. Since we have 3 plots of data, we need to give it 3 arguments. The order of the strings should match the order of the data sets. So since we've plotted X versus Y1 first, we should put Y1 in a string first, Y2 second, and then y3 third. This will produce a legend that's shown in the top right hand corner. Alternatively, we could make 3 calls of the plot command and use the hold on function to keep them all on the same figure. So for the first plot command, we have our first data set. We hold that figure, and on top of that, we're plotting the second and the third data sets. Again, make sure that you include all of the labeling and legend if necessary for all your plots. A figure may contain more than one window, each known as a subplot. Here we have an example where we have a 3x1 arrangement. 3x1 meaning 3 rows and 1 column. So this is the first row, second row, third row. We can set up the 3x1 subplot window by having the command subplot, the number of rows, and then the number of columns, and this is the panel number. So again, the panel number will be 1, 2, and 3. The panel number tells MATLAB which panel to plot in. So since we have a 1 there, the plot of x versus y1 as a blue line will be plotted in the first window. Again, we need to label X and Y1. For the second panel, we're plotting X versus Y2 as a red line. And thirdly, for the third panel, we're plotting X versus Y3 as a black line. And you can see the results of all of that in the figure on the right. Some plotting tips. Always specify a dependent and independent variable. The variables need to be of the same length. Use a legend when plotting multiple curves on the same figure. This will allow you and others to know which line represents what. As always, label your plots. And you can use the close all at the top of your script files. This will close all of the current figure windows before you start your script. Engineers regularly deal with multi-dimensional data, so a variable may be a function of multiple variables. This means that we need more than just 2D plots. And as with 2D plots, 3D plots can also allow you to visualize data in a quick and interpretive manner. Some syntax of commonly used 3D plotting functions are plot3, mesh, surf, and contour. I'll now go through an example of each of these plotting commands. For the first one, when using the plot3 command, which is the 3D line plot, when we're plotting a helix. So we'll use t as linspace from 0 to 10 pi with 200 points. Recall that 0 is the start, 10 times pi is the end, and the last argument is the number of points. Plot3 will then take in 3 arguments since we have 3 variables. So we have x, y, and z, which in this case is sine t, cos t, and t. Remember to label, and we'll also have the grid on in this example. The next example is viewing a 3D peak using the mesh command. Again, there are 3 variables, x, y, and z. X and y is created using the mesh grid command. The mesh grid command will create a matrix from the range of -2 to 2 for both the x and y directions. We can also view the surface of a peak using the surf command. And finally, we can look at the contours of a peak using the contour command. Here, the last argument represents the number of contours you wish to see. So as a summary, this video covered how to plot multiple datasets on the same figure window, how to create multiple subplot windows in the same figure, and that there's a lot more to plotting than just 2D datasets. As a final thought for this video, is it possible to plot on logarithmically scaled axes as opposed to linearly scaled axes?